Hello everybody, so today we'll be looking at this very interesting problem. This identity was discovered by Ramanujan. So 135 to the power 3 plus 138 to the power 3 equals x to the power 3 minus 1. So the first thing we want, and x is a positive integer. So the first thing we want to do is start considering the equation modulus m prime p. So basically we can rewrite this equation as x to the power 3 equals 135 to the power 3 plus 138 to the power 3 plus 1. And if we consider this equation, mod p for p equals 5 and 11. So if we consider this equation mod 5, basically 135 to the power 3 plus 138 to the power 3 plus 1. Basically 135 is congruent to 0, and 130 is congruent to 3 mod 5, which is a 3 to the power 3 plus the 1 mod 5. Now, if we consider it mod 11, that would be 135 to the power 3 plus 138 to the power 3 plus 1. Basically, the first term is congruent to 3, so it's 3 to the power 3. The other one is congruent to 6 and plus 1 mod 7, which eventually would lead to 2 mod 11. And that thing right over here is 3 mod 5. So basically, so far we've reached that x to the power 3 is congruent to 2 mod 11 and 3 mod 5. So that's easily solvable using the Chinese remainder theorem. So that would give us, so basically, since x to the power 3 is congruent to 2 mod 11, x is congruent to 7 mod 11, and x is congruent to 2 mod 5. So by the Chinese remainder theorem, x would be, so you can do it pretty easily, x would be congruent to 7 mod 55. So this is an important information about x. Now what we want to do is try and bound x between some two positive integers. So basically, x to the power 3, which is equal to 135 to the power 3 plus 138 to the power 3 plus 1. So that's less than 2 times 135 to the power 3, which means that x would be less than cubic root of 2 times 138. And this cubic root of 2, we have again to bound. We have to find like cubic root of 2 is less or equal than something. And what we're going to use here is the Bernoulli's identity. So it's pretty obvious that cubic root of 2 immediately reminds us to the Bernoulli's identity, which states that 1 plus a all to the power n is bigger than 1 plus na for a positive integer. So if we let cubic root of 2 be equal to some k plus 1, then k plus 1 all to the power 3 would be bigger than 3k plus 1. So basically that's 2, so 3k plus 1 would be less or equal than 2, implying that k would be less or equal than 4 over 3. So that means that x to the power 3 is less or equal than 4 over 3 times what? Times 138, which is equal to 184. So but now we know that x is less or equal than 884. So now we want something right over here. So from our initial equation, x is clearly bigger than 838 because it's equal to 838 to the power 3 plus 135 to the power 3 plus 1, which means that it might be a good idea to put here 838. So now we've kind of made that interval pretty small, and we're going to combine it with the condition that x is congruent to 7 mod 5. Sorry, mod 55. So basically the if it's pretty easy to look for an integer between 138 and 184 such that it's congruent to 7 mod 55. So that integer is 172. So basically x equals 172. So I hope you enjoyed today's video. Please do not forget to subscribe to my channel and like the video for more content.